A neuroscientist asked people to keep eating chocolate even after it stopped feeling good. What their brains revealed started a chain of discoveries that explains modern overeating. If you ever wondered why you keep eating or binging, even after the food stopped tasting good, this video will change how you see yourself. I'm Rita May, an emotional eating and binge eating coach, and I help you outgrow the version of you who needed food to cope. So let's see that experiment. In 2001, a neuroscientist named Dana Small asked people to eat Lindt chocolate even way after the feeling of satisfaction. And while they were eating, she scanned their brains. At first, the brain areas that are responsible for wanting the chocolate, the dopamine region, was very active. But the more people ate, the dimmer those signals became. And then the brain region responsible for avoidance turned on. It means that the brain doesn't just want food, it also knows exactly when to stop eating. So if the human brain knows when to stop eating, how does it know? Is it the taste, the pleasure, or something more complicated? And even more importantly for us, what happens when we overeat or binge eat? Why does the brain not know when to stop anymore? Years later, Dana Small worked at Yale next door to another neuroscientist called Ivan de Araujo. I hope I pronounced his name properly. He studied genetically modified mice who could not taste sugar at all. He gave them 3 bottles, one with water, plain water, one with sugar water, and one with even sweeter sugar water. So these mice can't taste sugar, right? They couldn't taste which one was sweeter, so they just drank randomly from these bottles. But after 6 days, something remarkable happened. Even though they couldn't taste the difference, they started to drink just like normal mice who could taste the sweetness. They drank the same amount with the same frequency. Their brains figured out where the energy was without being able to taste the sugar. And that region in the brain is the dopamine region. This brain region figured out which sipper contained the sugar and how much energy it contained, and even though the mice couldn't taste it at all. I actually explained in my previous video that dopamine is not responsible, contrary to popular belief, it's not responsible for pleasure and liking the food. It's responsible for wanting food. You can watch it here or here. So these sweet blind mice drank sugar water until this wanting region was switched off. So they didn't stop drinking because they didn't like it anymore, because they never liked it, right? They couldn't taste it, they couldn't like it. And they also didn't lick their paws and stick their tongue out. That would be a clear sign of enjoying it. They just drank like little robots and then stopped drinking, which tells us something very interesting. The brain doesn't stop eating because the food doesn't taste good anymore. It stops when it decides that the body received enough usable energy. It also shows that we have this internal system that can tell us when to stop eating perfectly well. We just messed it up with dieting and restricting, right? And it can also be repaired. And this is exactly what we do inside my group coaching programs and with my private clients. My next group coaching cohort actually opens up in March. So check out the link in the description if you want to stop binge eating, emotional eating, food obsession, yo-yo dieting. I can help you. Let's go back to the experiments. Once Araujo saw that the brain could track energy without taste, he pushed the experiment even further. In this experiment, he used normal mice that could taste sugar, and he gave them a choice between two drinks. The first drink was sweet, but it did not contain calories because it was sweetened with an artificial sweetener, sucralose. The second drink tasted disgusting, awful, extremely bitter. But every time they drank from this drink, real sugar was delivered straight into their stomach. At first, obviously, the mice started to drink the sweet drink, sweetened with sucralose, right? But very quickly, they completely abandoned this sweet drink and started to drink from the extremely bitter, disgusting drink. This experiment showed that the stomach isn't just a passive container digesting the food. It actually sends information about the food to the brain. The brain stores that information, processes it, and uses this information to predict future eating behaviors. Fascinating, isn't it? So taste can be overwritten because energy is more important. But Araujo went even further. In this next experiment, he blocked a mice's ability to turn sugar into energy. The mice could taste the sweet taste, right, the sugar, but their bodies couldn't use it. And once again, the mice stopped drinking it because it was useless, right? So it tells us that the brain doesn't really care about the taste of the food. It cares more about whether that food works for our body, right? And I mentioned that Dana Small was in the next room at Yale. And when she saw these results from Araujo, one thought immediately clicked. If the brain can track energy and communicate with the stomach in mice, is it the same with humans? Because if the same happens with humans, it could mean that modern foods with artificial sweeteners could completely confuse the brain's energy predicting system, right? But there was a problem. She couldn't just genetically modify people or inject sugar directly into their stomach. So she had to be very creative and design a very interesting experiment. In this experiment, she separated sweetness from calories without the participants knowing about it. She created 5 drinks. She sweetened all of them with the artificial sweetener, sucralose, and she added that much sucralose, so they tasted like a 75-calorie drink. But she actually changed the calorie content of these drinks, adding tasteless high-calorie carbohydrate, maltodextrin, to these drinks. So she made 5 drinks, one with 0 calories, one with 37.5 calories, one with 75, one with 112.5 calories, and one with 150 calories. But they all tasted like a 75-calorie drink, right? As I said before. And then when the participants drank the drinks, she scanned their brains. She was watching the dopamine system, the wanting system, to see which drink the brain would treat as most useful, right? The most valuable. Because if calorie mattered, then the 150 calories drink would have the highest response, right? Because that's the most valuable. But if taste mattered, then all 5 of them would be the same, right? Because they all tasted like a 75-calorie drink. But what happened next surprised everyone. But before I tell you what happened, I want to tell you a little bit more about my group coaching program starting on the 19th of March, because it's exactly for people who has confusion around hunger, feel like they can't stop eating, and they feel like food has so much power over them, too much power over them. And this is exactly what we solve inside Outgrown. We work on rebuilding trust with your body and your brain so eating can finally become neutral, just like food is food, nothing special, right? You like it, you like the taste of it, but there is no compulsion around it. It's just neutral and not exhausting anymore. And I also help you outgrow the person who needed food to cope, because there is also some emotional cause behind that overeating most of the time, right? This is going to be my first group cohort, so the price is the lowest that it ever will be. I only beta test this group format. The method itself worked very well for my private clients for 3 years. So it's a proven method. So if you are interested in being the founder member with loads of benefits, check out the link in the description below. So now back to the experiment. Dana Small actually expected that the 150 calorie drink would have the largest dopamine response in the brain because, after all, it was the most useful one, right? It had the most calories. But that's not what happened. The biggest dopamine response, the strongest wanting signal in the brain, came from the 75 calorie drink. The drink where sweetness and calories matched perfectly. It makes sense, right? Because all 5 drinks tasted like a 75 calorie drink. So when the brain received exactly 75 calories, it lit up and said, yes, this is what I predicted. This is useful. And when sweetness and calories didn't match, the brain response was flat. The brain didn't get excited. It didn't register value. And this tells us something crucial. The brain doesn't respond to calories alone. It responds to calories that match expectations. After seeing what happened in the brain, Dana Small asked the next obvious question. What's happening in the body with these calories? Do they affect the metabolism? Are they metabolized the same way? And this is where it shifts from being interesting to being disturbing. And this is going to be the topic of my next video. So make sure you come back and watch it. See you soon.